Folks, firstly, just to just to remove the gaps over the practice, maybe it could be multiple reasons. I'm just making this video and execution document just to tell you so that you can go ahead in practicing this. If you can able to complete this, more than enough that you're on track, right? Let's get started first of all, right? Firstly, this is a programming area, all right? So programming might look weird, but as of now, since the time gap we have, just complete this execution, all right? I'll give this compiler, Scala compiler URL. You can directly switch this, and this link would be there. Maybe a println statement would be there as hello world, remove it, all right? Now coming to the point, this area you can practice it to start it immediately. Later on, you can watch the video whenever it is available. But in this video, in the very high level, I'll tell you so that you can complete this first and get back on track first. All right. Now let's get started. We are going to use a language known as Scala. All right. We are going to use a language known as Scala. So in this language, all right, we are going to do a kind of a object-oriented programming and whatever. So I just created a document for you. The same document, you have the Scala URL container. So if you just open this URL here, the Scala compiler would open. All right. So this would open. So first, give a gap so that you can start doing this. All right. We can watch that video later, but complete this execution video first. All right. Now coming to the point. Now, this is area. So Scala starts with the keyword known as val. Okay. Type first, before we go with that, first type println statement. Println statement would print whatever you want. First, you have to give started so that it will print whatever you want. Just give an execute so that this gets executed here itself and show the results on the right side. All right. Just have a check on that. You'll see the output here. Let's get started from this point. Later on, you watch the whole video of the weekend, but let's get started from this point. Now, I want to start my practice. Since we're going to start with Scala, Scala start with something known as, you have to start any variable assignment with val. Val a is equal to 2. I'm just assigning a value 2 inside a variable. If you want to print this variable, just give println of a. Now, what am I doing? I'm just printing the value of a so that since 2 exists in this a, the println of a gets printed. So if you clearly watch out, started gets printed and 2 also gets printed in the right side because I am trying to print the variable of a. A holds the 2 number. In other words, if I have val b is equal to Zyabron, this time I'm going to assign a string, a word. Okay, it's not a number. So that's the reason I have to represent that as the double quotes. So if I try to print println of b, all right, this time I'm trying to print the variable of b, which holds Zyabron. Now, if I execute this particular command, it will load and it will print you Zyabron word as well, because I'm trying to print the B1. Complete this as a first execution. All right. Now, once it is completed, now you can go with the next one. All right. Now, this is just an integer a, b is just a string. Now, what we can do, all right, we can create a collection of data. Since 2 is only one number, Zyabron is just a word. Now, what you can do is, all right, now you can create your own list of data. Now, how can I do a list of data? Now, have a check. Val list in is equals list of 1, 2, 3, 4. This is a collection of data. Before, it used to be only one number and one string. But here, I have list of integers, 1, 2, 3, and 4. But it's not a straight away print in, like how I have printed integer or string. You have to use some other way to print the data. You have to use it as lsin dot for each println. The only difference between the previous println and this println is previous println is just a one number and one string. Here we have a collection of numbers, 1, 2, 3, 4. So you have to use listen dot for each println. All this code is available in this notepad. I'm going one after other. String, all right. This is started and integer print, string print. Now I'm printing list integer print. So if you clearly watch over, it prints all the data at a time. Since it is a list of data, multiple data, I have to use lsin dot for each println. Now I just created the list. but I need to process the data present inside because this is a collection of data. I have 4 variables in a list. Sorry, four values in a list. All right. Now to process any kind of a list data, okay, Scala has come up with one of the solution. Okay, if this is your list, imagine if this is your list. Now, if I want to process this data, suddenly I got a requirement. Create a new list with filter above list with values greater than 2. That means it is expecting the new list. It is expecting a new list, val new list is equal to, it is expecting only the list consists of 3 and 4. How to process this above list? Above list, I just have to iterate each element. All right. Then I have to create a new list that should hold only the values greater than 2. Okay. In Scala or Python and Java, we have a specific functionality to process any kind of a collection of elements. We got a new invention known as Lambda. Lambda will help you to process the data. Now, as a part of this code, how can I do the coding is val new list is equals, you have to filter this list, right? LSIN dot filter x lambda x greater than 2. This is what the representation should be. Okay. Just first I'll execute this and I'll show you what is the mechanism behind it. All right. Just do the same. You will understand it better. For each println, all right, give one of the, put one in between statement ones as filter list, all right, so that it will differentiate in the print. Just execute this. In the execution, you will say in the new list, it would hold only 3 and 4 here because I processed this data. Check. If you see, it started, this is the raw list and this is a filtered list. Okay. But what made this? How Lambda helped you to filter the data? Okay, let's come to Lambda. All right, check here. Basically, this is my raw list that holds the whole 1, 2, 3, 4 data, and this consists of filter data. All right, this consists of filter. I'm filtering this data with x lambda x greater than 2. All right. Now, if I want to process this list, now I'll tell you how it is getting processed. This is lambda. Okay. Left side of lambda, we call this x as accumulator. All right. In the right side of this lambda, we call it as a iterator. All right. We call this as a left side of lambda, we call it as accumulator. Right side of lambda, we call it as an iterator. What it will do is this ln is a representation of this ls. This iterates each and element. So what it will do is first 1 will come here to check the condition. Is it 1 greater than 2? No, this is not satisfied. Then 2 will come as a next iteration because it's an iterator. This is iterator, this is accumulator. Now x 2 greater than 2? No. Then 3 will come into picture. 3 greater than 2? Yes. Since this condition got satisfied, immediately that gets accumulated here because this is accumulated. Then 4 comes into picture. All right. 2 will see 4 greater than 2. Yes, it got satisfied. Immediately that gets accumulated. All this 3, 4 will be accumulated here. So that's the reason, depending on this operation. All right. Depending on this operation, this particular filter worked. Depends on this operation, this particular filter worked. So first 1 came here to get printed, folks. First 1 came here to check the condition, no. Then 2 came here to check the condition, no. 3 greater than 2, yes, it gets accumulated. 3. 4 comes here, gets accumulated. 4. These 3, 4 will be accumulated here. So finally, if you print this LSN, you will see this. Now let's check the next example. All right. I'm giving the new code known as find a new list lesser than 2. This time it's lesser than 2. I'm expecting only 1, 2, not greater than 2. Not greater than 2. I'm expecting one, lesser than 2. So what will happen? I will change this code as lesser than 2. So what will happen? Basically, if I change this code as lesser than 2, here, first element will come as 1. Right? First element will come as 1. you'll get it as 1 less than 2. Yes, it is getting satisfied. 1 gets accumulated. Then 2 lesser than 2? No. 2 is equal to 2 actually. So it will not get accumulated. 3 lesser than 2? No. 4 lesser than 2? No. So in this case, what will happen is just execute this code. All right. Just execute this code and execute it. So each element will come for the iteration. Whoever, in this case, we have only 1 gets accumulated here because 1 is the only thing which satisfies this condition at the right. So only this gets accumulated. And finally, you'll see only 1 as a list. So in case of my lambda expects the same variable left and right. All right. But right works as an iterator, which iterates each and every element to check the condition. Left one works as an accumulator. This is what a lambda function is. Hope you got some idea right now. Kindly, I just kept all the details here itself in one of the documents. I'll be giving this document so that it will help you to check everything. All right. Now, this is the filter. This is the filter. Now, suddenly I got a new requirement. Imagine, okay, imagine I got a new requirement. Create a new list with, okay, you can say, create a new list with the above list should be iterated and multiplied with 2. Okay, what they're asking us is iterate each element of this list and multiply that element with 2. Okay, now definitely filter will not work because we are not filtering anything, but we are doing the multiplication. Okay, we are doing the multiplication. In this case, if you got a time, okay, I have to do the multiplication. All right, what is actually this do mean is this is no more a filter. I'm doing an operation. If you got in thoughts, hey, I'm going to do something. Okay, I'm going to do means yes, I'm going to do the replacement, do the multiplication, do the division. It's no more a filter, folks. It is doing something. If that is the case, what you have to do is val mul list is equals to, definitely I have to iterate and I have to use lambda, but it's no more a filter. It is map. Map means doing something. Okay, it's not a filter. I'm not checking less than or greater than 2. I'm doing the multiplication. When do comes into picture, you have to use map. So map x lambda x into 2. In this case, what it will happen is first element will come, gets multiplied and gets accumulated. 2 gets accumulated. Second element will come, 2 into 2, 4 gets accumulated. 3 into 2, 6 gets accumulated. 4 into 2, 8 gets accumulated. All together, this will go into mul list. So let's execute and check this scenario, whether my multiplication is working. All right. Okay, this is map list. I'm giving the check here as map list. All right. Now let's check whether mul list is working. Execute this. Each element will come here, gets accumulated. 1 gets come, multiplied, accumulated. 2 gets come, multiplied, accumulated. 3 comes, multiplied, accumulated. 4 comes, multiplied, accumulated. So finally, you'll get the output as 2468 like this. So if you got in thoughts, hey, I'm going to do something, not the filter. If I'm going to do the multiplication, if I'm going to do the division, if I'm going to do the replacement, whatever, do comes as map. Clear? So complete this operation. I also mentioned in the same document. Okay, multiplied integer. All right. Now, this is completed. Integer side is completed. Now see the other face of it. All right. Now see the other face of it. Now what I'm going to do. All right. See, so far we just handled list of integers. Now what we are going to do, we are going to assign a list str is equal to list of, this time list of strings. It's no more a list of integer. Ziobron, Zio, Analytics, Azio. All right. In this case, this is no more a list of integer. This is list of strings. So if I have a list of strings, all right, So this is how the implementation would work. Print is going to be the same because since it's a list, print is going to be the same. List str dot for each println. Now execute this. All right. You'll print each and every element. Ziobron, Zayo, Analytics, and Azayo. It gets printed here one after other. All right. It got printed. Now I want to process this list. Processing the list is going to be the same. Have a check. Now I have this list, right? I have this list. All right. Now in this list, I want to iterate each and every element. Now I want to iterate each and every element and process. And okay. And I want to process. I want to filter and string consists of Zayo. I want to process each element, have above list, and filter elements contains Zayo word. Actually, the Zayo word exists in this element, and this element. So they're expecting a new list that holds only the Zayo elements. Now, to create a new list, now check val fill str is equal to, I'm going to filter the strings. All right. I'm going to filter the list. Now, how I can do this list is, all right. 1 sec. Okay. How I can do this list is list str dot, definitely it's a filter. It's not a do something. It's a filtering something. Filter x lambda x dot contains gymnastics. Sorry, Zayo. What it will do is, first element will come here. Ziobron will come here. Contains Zayo. Yes, gets accumulated. Ziobron gets accumulated. Zayo will come. Yes, that contains Zayo. Gets accumulated. Analytics will come. That doesn't consist of Zayo. It will not accumulate. Zayo consists of Zayo. It gets accumulated. So, in this case of my string, to filter the data, see, lambda is going to be the same. Left works as an accumulator, right works as an iterator. It will iterate each and every element. If the filter condition got satisfied, it would accumulate. Copy this, paste it here. I'm giving another println statement to differentiate the statements. Filter str, okay, and do this filter fill str dot for each println. Now run this. Now, if you run this particular output, each element will come. Ziobron will come. Zayo will come, gets accumulated. Analytics will come. It will not get accumulated, but Azayo will come, gets accumulated. Finally, we have the fill str. That's the reason we got only 3. This is the next example. All right. Please do it. Next output. Okay. Next use case. See the use case. You have above words like this. Now, what you have to do is, using above list, iterate each element, and replace Zayo with Terra. Okay, that means this is no more a filter. It's asking us to do the replacement. That means map would come into picture to handle this scenario. All right. Val map str is equal to list str dot map x lambda x dot replace Zayo with Terra. This is how we work. So if you clearly watch over, first element will come, gets replaced, and gets accumulated. The Zayo gets replaced. Zayo will come and gets replaced. Analytics will come. Nothing is there to replace. So analytics will usually get accumulated. Because this is not a filter, it's a map. If you have Zayo, replace it. Zayo will come and replace it. Now execute this code. So the above list gets iterated. Okay. I'm giving the println as replace str. All right. And giving this as a map str dot for each println. Now, what will happen? Each Ziobron will come, gets replaced, accumulated. Zayo will come, gets replaced, accumulated. Analytics will come, it will map, but there is no Zayo to replace. A Zayo will come and gets replaced. And finally, I'll get a proper list consist of Terra Braun, Terra Analytics, and A Terra, because Zayo got replaced.